Imagine you're a scientist who has been waiting for years to see the largest asteroid sample ever collected by a space mission. You finally get to open the capsule that contains the precious material from a distant and mysterious world. But as you lift the lid, you see something that shocks you. A layer of black dust and debris covers the inside of the canister, and the sample weighs more than what you expected. Where did this extra material come from? And what does it tell you about the origins of our solar system and life itself? This is not a science fiction story. This is what actually happened to NASA's OSIRIS-REx mission, which returned to Earth with a sample from Bennu, a potentially hazardous asteroid that acts as a time capsule, offering a glimpse into the early solar system's composition. In this video, we will tell you the amazing story of this mission, how it collected the sample, how it brought it back to Earth, and what it discovered inside the capsule. We will also tell you why studying asteroids is so important for understanding our cosmic past, present, and future. The OSIRIS-REx mission, which stands for Origins, Spectral Interpretation, Resource Identification, Security, Regolith Explorer, was launched on September 8, 2016, from Cape Canaveral Air Force Station in Florida. Its destination was a small, dark, and rocky asteroid named Bennu, which orbits the Sun at a distance of about 200 million miles from Earth. Bennu is a fascinating object for several reasons. First of all, it is one of the oldest and most primitive asteroids in the solar system, dating back to over 4 billion years ago. It is composed of materials that have not changed much since the formation of the planet. It is like a time capsule that preserves the history of our cosmic past. Secondly, Bennu contains organic molecules, which are the building blocks of life. Scientists believe that asteroids like Bennu may have delivered these molecules to Earth through impacts, providing the ingredients for life to emerge. Thirdly, Bennu is a potentially hazardous asteroid, meaning that it has a chance of colliding with Earth in the future. In fact, on September 25, 2135, Bennu will make a close flyby of Earth at a distance of only 185,000 miles, which is less than half the distance between Earth and the Moon. This encounter will alter Bennu's orbit and make its future trajectory unpredictable. Scientists estimate that Bennu has a 1 in 150,000 chance of impacting Earth in 2068. With these reasons in mind, NASA decided to send OSIRIS-REx to Bennu to collect a sample from its surface and bring it back to Earth for analysis. The spacecraft arrived at Bennu on December 3, 2018, after a 2-year journey covering 1.4 billion miles. It entered orbit around Bennu and began mapping its surface in detail. The next challenge was to select a suitable site for sample collection. This was not an easy task, as Bennu turned out to be more rugged and boulder-strewn than expected. After months of careful evaluation, OSIRIS-REx chose a site called Nightingale, located in a crater near Bennu's north pole. The most thrilling phase of the mission was the sample collection event on October 20, 2020. OSIRIS-REx used a robotic arm called TAGSAM, Touch and Go Sample Acquisition Mechanism, to collect the sample. The arm had to touch Bennu's surface for only a few seconds and release a burst of nitrogen gas to stir up dust and rocks into its collection chamber. This was a high-stakes, one-shot operation, as OSIRIS-REx had only enough nitrogen gas for 3 attempts. To everyone's delight, OSIRIS-REx executed the maneuver flawlessly and collected a remarkable 300 grams of sample, exceeding NASA's expectations by 5-fold. The mission team celebrated this historic achievement with joy and relief. However, there was a problem. Some of the rocks collected by OSIRIS-REx were too large to fit into the sample chamber, causing a flap to jam open. This allowed some of the precious material to escape into space. To prevent further loss, OSIRIS-REx quickly stowed the sample in a capsule and sealed it for the return journey. On May 10, 2021, OSIRIS-REx bid farewell to Bennu and began its voyage back to Earth. It took about 4 months for the spacecraft to reach Earth's vicinity. On September 24, 2023, OSIRIS-REx released the capsule containing the asteroid sample and directed it towards Earth. The capsule entered Earth's atmosphere and deployed a parachute to slow down its descent. The capsule safely landed at the Utah Test and Training Range on September 26, 2023. A recovery team retrieved the capsule and transported it to NASA's Johnson Space Center in Houston for analysis. 2 days later, scientists opened the capsule for the first time. They were eager to see the asteroid sample that they had waited for so long. But what they saw was not what they expected. As they lifted the lid of the capsule, they were met with a surprising sight. A layer of black dust and debris covered the avionics deck of the canister. Even more astonishing, the sample weighed 100 grams more than what was originally collected at Bennu. How did this happen? Where did this extra material come from? The mystery began to unravel as scientists examined the dust and debris. They realized that it was not contamination from Earth, but rather material from Bennu itself. They hypothesized that when OSIRIS-REx touched Bennu's surface, it generated a shockwave that spread across the asteroid. This shockwave caused some material to be ejected into space at high speed. Some of this material trailed behind OSIRIS-REx and adhered to its outer surfaces. A portion of it entered the sample canister through the open flap and mixed with the collected material. The total mass of the sample, including the dust and debris, now measured around 400 grams, exceeding scientific requirements by 8-fold. This was an unexpected bonus for NASA, as it meant more material to study and understand. However, the presence of dust and debris also posed some challenges for scientists. They had to handle and clean it carefully, without damaging the electronics or losing any material. They also had to document and catalog each fragment of dust and debris, as they were integral components of the sample inventory. The next step was to analyze the sample in detail using various instruments and techniques. Scientists hoped to learn more about Bennu's composition, structure, history, and potential as a resource for future space exploration. Why is studying asteroids so important? Because asteroids are considered time capsules that preserve materials from the early solar system when planets were forming. They contain materials similar to those found on Earth, but have not been altered by geological processes. By studying asteroids like Bennu, we can gain insight into how the planets formed and evolved, and what makes Earth unique and habitable. Another reason to study asteroids is that they may hold clues to the origins of life. As we mentioned earlier, asteroids like Bennu contain organic molecules, which are the building blocks of life. Scientists believe that these molecules may have been delivered to Earth by asteroid impact, providing the ingredients for life to emerge. By analyzing the organic molecules on Bennu, we can learn more about how life began on Earth and whether it exists elsewhere in the universe. A third reason to study asteroids is that they pose a potential threat to Earth. Asteroids are constantly moving in space, and some of them cross Earth's orbit. These are called near-Earth objects, or NEOs. If a NEO collides with Earth, it can cause devastating damage, depending on its size and speed. For example, the asteroid that wiped out the dinosaurs 65 million years ago was about 10 kilometers in diameter and hit Earth at 20 kilometers per second. That's why NASA is interested in studying NEOs and assessing their impact risk. The OSIRIS-REx mission is now renamed OSIRIS-APEX, focusing on studying the near-Earth asteroid Apophis. Apophis, approximately 1,100 feet in diameter, will have a close approach to Earth in 2029 and is estimated to pose a 1 in 150,000 chance of impacting Earth in 2068. OSIRIS-APEX will arrive at Apophis in April 2029, studying the asteroid from orbit to gather essential data for Earth's protection against potential asteroid impacts. By studying Apophis, OSIRIS-APEX will also test new technologies and techniques for asteroid deflection, such as the gravity tractor method. This method involves using the spacecraft's gravity to tug the asteroid away from its original path, avoiding a collision with Earth. In summary, the OSIRIS-REx mission's surprise discovery of additional material in the asteroid sample, along with dust and debris on the spacecraft, has raised intriguing questions about the early solar system and the origins of life. The study of asteroids remains vital in uncovering the secrets of our cosmic past, understanding the potential threat they pose to Earth, and even hinting at the origins of life itself. The renamed OSIRIS-APEX mission will further our knowledge of near-Earth objects and enhance our ability to protect our planet from asteroid impacts. Thank you for watching this video. We hope you enjoyed it and learned something new. If you did, please give it a thumbs up and share it with your friends. And don't forget to subscribe to Cosmic Hunt X and hit the bell icon to get notified of our latest videos. We'll see you next time on Cosmic Hunt X, where we explore the secrets of the universe.